Okay, so this section of A math, right, is something very new. It's something called logarithm. Okay, so actually so at the moment you wouldn't know what is logarithm. So you are going to see logarithm as the cousin of indices. Okay, so first of all, I'm going to introduce logarithm as the cousin of indices. Okay, so that means it's somehow related to indices. So if you recall about your indices, so what are the components in your indices? You actually got a base, you got a power, and then you eventually got an answer. Or you can call that a value. So a base, a power, and an answer. So there are three components in indices. So we're going to be arranging these three components. We're going to be arranging the three components. The three components will be arranged in this way. Okay, so the base is here. Okay, the answer is actually here, and the power is actually here. So it's something like this. So it's the base, when you write the base, right? So for example, if you're writing on Foolscap, okay, so you write a G. So this is so you make sure the base is kind of at the bottom. So try to write it at the bottom of of the letter G. Okay, so first of all, you need to rearrange a component of the indices into a logarithm format. So this can be interchanged. So this is kind of interchangeable. So some students for a start, they will be like, what am I supposed to remember? So of course, you need to remember where you place the base, where you place the power, where you place the answer. So there's actually a simple way I did it myself. So personally, I do it this way. Base pushes up the power, and it gave me the answer. So actually this circle thing is in my head whenever I do logarithm. So the base push up the power and it gave me the answer. So I look at it as a circular motion. Okay, so your job is to be able to translate between indices and logarithm. So I'm going to show you two examples in the translation. So subsequently, the translation or the switch in between indices and log will form the foundation of this topic. So anytime we can come back to the switching in between of log and indices. Okay, so in example 1, I got 5 square equal to 25. The base is a 5. The answer is a 25. The power is a 2. And you can check whether you're correct or not. 5 square is giving you a 25. Okay, so you can always check in the circular motion. So the base here is a 12. The answer is 1. And the power is 0. So 12 to the power of 0 is equal to 1. Okay, 7 cubed equal to 343. The base is 7. The answer is 343. The power is 3. So it's 7 cubed, giving me a 343. Okay, so the next one. The base is a 3. The answer is a 1/3. The power is a -1. So 3 to the power -1 is giving me 1/3. 1/8 is 2 to the power of -3. The base is 2. The answer is 1/8. The power is -3. So 2 to the power of -3 is giving me 1/8. Okay, 6 cubed equal to 216. That means the base is a 6. The answer is 216. The power is a 3. So 6 to the power of 3 gave me a 216. So this is just my way of switching in between indices and log. You can come up with your own way once you're familiar with it. Okay, so because I got this method, okay, sorry, there's a typo here. So because of this method, if I need to change the log back to indices, it's actually very easy. It's 2 cubed equal to 8. 5 to the power of 4 equal to 625. 2 to the power of minus 1 gave me a half. So 9 to the power of 0 gave me a 1. 6 to the power of minus 2 gave me a 1 over 36. Then 10 to the power of 3 gave me 1000. So that's how I change in between indices and logarithm. So this being the foundation, you will need to be able to do first. Then subsequently, there will be things like logarithm equation. Okay, and there will be the law of logarithm. There are only 5 laws compared to indices, there are 10. Okay, so you need to be very fluent within the 5 law of logarithm. So right now, this is the foundation to change in between indices and logarithm.